We have already discussed that matter in gaseous state will have some special characters than when it was in a solid or in a liquid state. Out of those special characters, the most important character of matter when it is in gaseous state is diffusion. Diffusion means the movement of gas molecule from one place to another place, or traveling of gas molecule from one point to other point is said to be diffusion. Suppose one of you have came into the class with a perfume, then immediately if you enter into the classroom, every one of the classroom will have that pleasant smell. That means the spray which he used on his clothes, that's good smell, that is in the gaseous state. They are in the vapor state. Those vapors reaches our nose. That's why we are able to identify that smell. So whatever the matter, whether it is a good smell or a bad smell, when we are observing or we are feeling it, means those particles are traveling from its origin to our nose. The property of the movement of that particle in a gaseous state is said to be diffusion. Graham studied the diffusion, the rate of diffusion of different gases, and he concluded that rate of diffusion of a gas is directly proportional to 1 by square root of its density. That means the rate of diffusion is inversely proportional to the square root of its density. Now, what is rate of diffusion? Rate of diffusion means the volume of the gas that diffused in a unit time is said to be rate of diffusion. So, rate of diffusion is equal to volume of the gas diffused by time taken for diffusion. Volume of the gas diffused and time taken for diffusion is said to be rate of diffusion. So, rate of diffusion R is equal to the volume of the gas that diffused in a unit time is said to be rate of diffusion. R is V by T, where V is the volume of the gas diffused and T is the time taken for diffusion. Now, Graham stated that the rate of diffusion of a given mass of gas is inversely proportional to the square root of its density. The rate of diffusion of a gas is inversely proportional to the square root of its density. Now, what is density? Density is the mass of unit volume is said to be density. So, density means mass of the gas by volume of the gas. Mass of the gas by volume of the gas is said to be density, and density is denoted with small d. Density is denoted by small d. So, rate of diffusion R is directly proportional to 1 by root d. This is mathematical expression for rate of diffusion of a gas at constant temperature and pressures. It is most important. Constant temperature and pressures. At constant temperature and pressures, the rate of diffusion of a given gas is inversely proportional to the square root of its density. This is Graham's law. Diffusion. Diffusion means the movement of gas molecules from one place to other place. The traveling of gas molecule from one place to another place. So, the rate of diffusion, that means the volume of the gas that diffused in a unit time, or the distance traveled by the gas molecule in a unit time. So, rate can be defined two ways: the volume of the gas that diffused in unit time, or the distance traveled by the gas molecules in a unit time is also said to be rate of diffusion. So, the rate of diffusion of a gas is inversely proportional to the square root of its density. Mathematically, we can express it like this: R is directly proportional to 1 by root D. R is directly proportional to 1 by root D, where R is the rate of diffusion and D is the density of gas. Now, let us consider or compare two different gases, where R1 and R2 are the rate of diffusions. R1 and R2 are the rate of diffusions, and D1 and D2 are their densities. For the first gas, R1 is directly proportional to 1 by root D1, and R2 is directly proportional to 1 by root D2. Then R1 by R2 is equal to root of D2 by D1. This is one form of Graham's law of diffusion. This is one form of Graham's law of diffusion. Diffusion, the movement of gas particle from one place to another place, or the traveling of gas molecule from one place to another place, is said to be diffusion. The volume of the gas, the amount of the gas, or the volume of the gas that diffused in a unit time is said to be rate of diffusion. Or we can say that the distance traveled by the gas molecule in a unit time can also be called as rate of diffusion. Now, Graham studied the rate of diffusions of different gases under different conditions, and finally he concluded that the rate of diffusion of any gas at constant temperature and pressures is inversely proportional to the square root of its density. The rate of diffusion of any gas at constant temperature and pressures is inversely proportional to the square root of its density. What is density? Density is mass by volume. At a given conditions, if mass of the gas is m and volume of the gas occupied is V, then m by V is d, small d, density. Density is mass by volume. Therefore, the Graham's law mathematically can be expressed as rate of diffusion or is directly proportional to 1 by root d, where small d is the density of the gas. Now let us consider two different gases, and the rate of diffusions are R1 and R2, and their densities are D1 and D2 respectively. When we apply Graham's law for these two gases, for the first gas, rate of diffusion R1 is directly proportional to 1 by root D1, And for the second gas, R2 is directly proportional to 1 by root D2. Then R1 by R2 is equal to root of D2 by D1. This is one form of Graham's law of diffusion. Now, if 1 mole of gas was taken, the mass of the gas will be equal to its molecular weight. When two different gases, 1 mole of two different gases are considered, their masses will be in the ratio of their molecular weights, and at same conditions of temperature and pressures, both the gases will occupy same volume. So let's consider two different gases which molecular weights are M1 and M2. M1 and M2. If these two gases are taken in equal number of moles, their masses are in the ratio of their molecular weights. If these two gases are considered or measured at same conditions of temperature and pressures, then their volumes are equal. Their volumes are equal. Now, the density of first gas D1 is equal to M1 by V and D2 is equal to M2 by V. D1 is equal to M1 by V, D2 is equal to M2 by V, where M1 is the molecular weight of first gas and D1 is its density. M2 is the molecular weight of second gas and D2 is its density. V is the volume. Since the two gases are at same conditions of temperature and pressures, they occupy same volume because their number of moles are same. Since their number of moles are same, their molecular weights are, the masses are in the ratio of their molecular weights. So now, then D2 by D1 is equal to M2 by V into V by M1. V cancels. It is M2 by M1. Therefore, D2 by D1 is equal to M2 by M1. Previously we derived that R1 by R2 is equal to root of D2 by D1. So, it will be equal to M2 by M1. That means the rate of diffusions will be related with molecular weights just like their densities. That means the rate of diffusion of a gas is inversely proportional to the square root of its molecular weight. The rate of diffusion of any gas is inversely proportional to the square root of its molecular weight at constant temperature and pressures. At constant temperature and pressures, the rate of diffusion of a gas is inversely proportional to the square root of its molecular weight as well as square root of its densities. So, here R1 is the rate of diffusion of first gas and R2 is the rate of diffusion of second gas. So, when two gases are comparing, R1 by R2 is equal to root of D2 by D1, that will be equal to root of M2 by M1. Now, we know that vapor density into 2 is the molecular weight. Vapor density means the density of gas with respect to hydrogen gas is said to be vapor density. Since molecular weight of hydrogen is 2, the vapor density of the other gases will be half of its molecular weight. So, vapor density Vd is equal to molecular weight by 2. Vapor density is molecular weight by 2. So, for two different gases which molecular weights are M1 and M2 and their vapor densities are Vd1 and Vd2, then M2 by M1 is equal to Vd2 into 2 by Vd1 into 2. Because 2 into vapor density is molecular weight. Now 2 cancels. Therefore, 2 by m1 is equal to Vd2 by Vd1, where Vd is the vapor density. Therefore, root of 2 by m1 will also be equal to root of Vd2 by Vd1. We have already relation that R1 by R2 is equal to root of d2 by d1 is equal to root of m2 by m1 is equal to root of Vd2 by Vd1, where Vd2 is the vapor density of second gas and Vd1 is the vapor density of first gas. Now, rate of diffusion, we have already discussed that. Rate of diffusion is the volume of the gas that diffused in a unit time is said to be rate of diffusion. Now, let us consider two different gases. Let it be, one is oxygen and other one is nitrogen. One is oxygen and other one is nitrogen. Now, these two gases, here we are taking two gases. Now, the volume of this gas is V1 and volume of this gas is V2. And both these gases were allowed to diffuse for T seconds. Since the molecular weight of these two gases are different, this gas volume diffused by oxygen, the volume of the oxygen that diffused is V1 in T seconds, whereas volume of the nitrogen that diffused in T seconds is V2. Because the molecular weight of the two gases are different. When they were allowed to diffuse at same time, T seconds, both are in two different containers. Now let us open its lid. Two gases are at same conditions of temperature and pressures. Now if you open the lid and allow them to diffuse for T seconds, then the volume of the gas that escape out of these containers are different. Now let the volume of oxygen that escape out is V1 and volume of nitrogen that escape out is V2. Then rate of diffusion of O2, R1 is equal to V1 by T and R2 is equal to V2 by T. Because rate of diffusion, volume by time is said to be rate of diffusion. Now, if you compare these two gases, R1 by R2 is equal to V1 by T into T by V2. So, here T cancel, it will be V1 by V2. R1 by R2 is equal to V1 by V2. We have already the relation. R1 by R2 is equal to root of D2 by D1 is equal to root of M1 is equal to root of Vd2 by Vd1 is equal to root of, sorry, there is no root here, is equal to V1 by V2. V1 by V2. Now, another case. The two gases, hydrogen and nitrogen was there. Both the volumes of these two gases are same, that is VV, because equal volumes of nitrogen and oxygen were kept in one container. Now, we are open the lid and allow them to escape the whole gas. Now, in such cases, both the volumes of the gases are different. Since their molecular weights are different, rate of diffusions are different. When the rate of diffusions are different, the time taken for the diffusion of these two gases will be different. In the previous case, we had taken two gases at same conditions of temperature and pressures. We allow them to diffuse under same time. We allow them to diffuse for T seconds. So, the volume of the gases that diffused are different. One gas is V1 and other gas is V2. Now, in the present case, equal volumes of gases are taken and allow them, the whole gas to diffuse. In such a case, the time taken for one gas is different from the time taken for the other gas. Because both the volumes are same, but diffusion timings will not same because their molecular weights are different. So let the time taken for oxygen is T1 seconds and time taken for nitrogen is T2 seconds. Then rate of diffusion of oxygen is R1 is equal to V by T1 and R2 is equal to V by T2. Then R1 by R2 is equal to V by T1 into T2 by V. So V cancels. So R1 by R2 is equal to T2 by T1. Now you substitute here. R1 by R2 is equal to root of D2 by D1 is equal to root of M2 by M1 is equal to root of VD2 by VD1 is equal to root of V1 by V2 is equal to root of T2 by T1. T2 by T1. So here these are the relations between the gases with their densities. Now you can compare the density of the gas with the volume of the gas to be diffused, or the density of the gas with the time taken for diffusion, or the molecular weight of the gas to time taken for diffusion. So if you know any three of the things present here, you can calculate the fourth one. Let us do some problems. The rate of diffusion O2 is 0.6 liters per second. Under same conditions, what is the rate of diffusion of N2? Rate of diffusion of N2. Now what are the things given here? Here two gases were given. One is oxygen and other one is nitrogen. One is oxygen and other one is nitrogen. The rate of diffusion of one gas was given. They are asking the rate of diffusion of second gas. Here we should remember the molecular weights of the important gases. We know that oxygen molecular weight is 32 and nitrogen's molecular weight is 28. So one is oxygen, first gas is oxygen and second gas is nitrogen. First gas is oxygen and second gas is nitrogen. Oxygen. First gas is oxygen and second gas is nitrogen. Now molecular weight of oxygen M1 is equal to 32. Molecular weight of nitrogen M2 is equal to 28. Then rate of diffusion R1 is equal to 0.6 liters, when R2 is equal to how much? So here molecular weights are given, rate of diffusion of one gas was given, and they are asking for rate of diffusion of second gas. Now here we have the whole relation. So here any two can be used here according to our requirement in the problem. Here we have comparison with rate of diffusions with molecular weights. So the rest of the things are not necessary for us. So R1 by R2 is equal to root of R1 by R2 is equal to root of M2 by M1. R1 by R2 is equal to root of M2 by M1. Here R1 is equal to 0.6 per second by, because they gave oxygen's rate of diffusion. So here R1 is oxygen and its molecular weight R2 is equal to root of M2, that is nitrogen, by 32. 0.6 by R2 is equal to root of 28 by 32. On simplification, you will get R2 value. Here, remember students, here for simplifications, you should know the logarithms using of logarithm tables. By using logarithm tables, we can easily do these calculations. Or in logarithm books, you have square roots also. In your logarithm books, you have square roots. From these square roots, you should know the root 28, values of root 28 and root 32. Now verify your logarithm books. So root 28 value is 5.29 and root 32 is 5.65. So on substituting those values, R2, so 0.6 by R2 is equal to 5.29 by 5.65, because 5.29 is the root 28, whereas 5.65 is root 32. These are the square root values of molecular weight of nitrogen, and this is molecular weight of root value of molecular weight of oxygen. Then R2 on cross multiplication, R2 is equal to 0.6 into 5.65 by 5.29, 0.64 liters per second. This is the rate of diffusion of nitrogen gas. So here rate of diffusions were given. Two gases were given. If the gas name was given, that means its molecular weight was given. So here you have to compare rate of diffusions with molecular weights. Sometimes they will give you the volume. Say at certain conditions 25 or 250 cc of oxygen is diffused, and under the same conditions what is the volume of carbon dioxide that diffused. That means in such cases you should compare the molecular weight this volume.